All right, so here we go for 5.7. 5.7. All right, hopefully this pen's working. It wasn't earlier, but it appears so. All right, so a squared plus b squared equals c squared. I'm going to be using that a lot. And again, if it's a right triangle, only this works. But if it is a right triangle, then this definitely works. All right, so in this case, our hypotenuse is x. So 3 squared plus 9 squared equals x squared. And then we have, I didn't grab a calculator, but I should handle these pretty okay. Equals x squared. So we get 90 equals x squared. And then we can take the radical of both sides. So we get x is going to be, so radical 90 is going to be 9 times 10. So it's going to be 3 radical 10. All right. In this case, we have the hypotenuse. We're missing a leg, so we can just say sort of like x squared plus 7 squared, right? Those are the two legs, equals 11 squared. So we get 49 equals 121 and x squared. So x squared equals 121 minus 49. I'm going to pull up a calc here just so it'll be easier. But 121 minus 49, 72. And then we can do radical 72, but all right. So 72 and then radical 72. So x is just going to be, well, that's 36 times 2, so 6 root 2. All right, in this case, we have two sides with variables, but they have the same variable, so we can still do the Pythagorean theorem. It's going to be our legs, right? Our first one is x minus 2 squared. Plus b squared, which is our 8 squared, equals our x squared, which is our hypotenuse. And then we're going to have to FOIL that. So x squared minus 4x plus 4 plus 64 equals x squared. All right, a couple of good things happen. Subtract x squared from both sides. See x squared. We get 68, so we get negative 4x equals negative 68. And so that would be 17 when I divide. X is 17, which we got. That's what we're looking for. All right. Pythagorean theorem. Awesome. All right. Find the missing side length. Tell if it forms a Pythagorean triple. In this case, it wants you to do 3, 4, 5, but it's not because the hypotenuse isn't 5. So we would just say something along the lines of, 4 squared plus 5 squared equals, like, in this case, we're trying to find c, so c squared. So 16 plus 25, so that's 39 equals c squared. And that's 3 times 13, but that's it. So it looks like just radical 39 is what we're going to get, and that's okay. So that would be a no, not a triple. For those reasons. All right, so in this case, we would be having a 3, 4, 5. So I can do this without a, so the triples are 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, and 25. Of course, that's any variation on those two. So again, that would also be, 6, 8, 10, or a 9, 12, 15, right? Or a 12, 16, 20. In other words, this is going to be 3 times 4, right? So to multiply by 4. This is going to be 4 times 4. And so this is going to be 5, 3, 4, 5. Shoot, I made that up. That's going to be 4 times 4 there. They're not going to be a triple. Good to know the triples anyway. But again, they are thinking about it, and actually that is right. So it's going to be, this was actually 5 times 4. So I was right and then wrong, and followed by now right again. All right, so 3 times 4, and this is, so it multiplied by 4. This is 5 times 4, right? Still by 4, and so this has to be 4 times 4, or 16. So I can do that without, but that's going to be sort of this triple right there. And of course, the other ones, you can double all of them, 10, 24, 26, 16, 30, 34, right? So you can double, keep them in mind. Okay, tell if they're going to be the side lengths of a triangle. If so, classify it. So as long as the two smallest sides are bigger than the third, we're good. So basically, yes, it can be a triangle. Yes, it can be a triangle, and yes, it can be a triangle. Okay, so now we got to classify it. So basically what we're doing is we're basically just separating a squared on one side and c squared on the other. So 12 squared, and then 7 squared plus 10 squared. So this is going to be 149. This is going to be 144, right? So in this case, we'd say c squared is smaller. So if c squared is smaller, again, I wouldn't need to write this out, but c squared is smaller, therefore acute. All right. In this case, we're separating these. So we have 15 squared, which is 225. We get 121. Oops, well, that's 11 squared. I could just write that out, I guess, for now. That's totally the best 11 squared in the world. So we get 81 plus 121. And this won't get that high. This is going to be, what, 202. So when we compare them, we know that 15 squared is bigger, right? So in other words, c squared is bigger. So c squared bigger, obtuse. Man, these in my head. Hopefully we don't make the mistake. 940. Okay, so this is 81 plus 1600. And this is 1681. I really don't know that. I'm guessing that this is a right triangle, but okay, I think it is. I think it's a triple if I'm not mistaken. But so anyway, 1681 equals 1681. So in other words, a squared plus b squared equals c squared. Therefore, it's a right triangle. I'm going to actually do that out so I don't move on. So 41 squared is what I'm looking for here. Calculator. 41 times 7, 41, 1681. Okay, I was right, but I didn't know I was. But now I do, and that's great. Okay, so in this case, 6, 8, 10, that is 1. That doesn't need any more work. You could do 6 squared, plus 8 squared equals c squared and solve it, blah, blah, blah. You could, but we don't need to because we're awesome and remember that triple. All right, so in this case, we get 9 squared plus x squared equals 13 squared. So 81 plus x squared equals 169. And so x squared equals 169 minus 81. 88. Oh, yes. 88 keys on a piano, just so you know, on a standard piano, I guess. So x equals, well, that's going to be, let's see, we could do, let's see, that's 4 times 22, right? So that's 2 root 22. 22 is 2 times 11, so that one would be, so 2 root 22 is going to be that one, which is actually my favorite number. So in this case, we have some legs, we got the hypotenuse, so our legs are x and 7, so our 2 legs, add them up, a squared plus b squared. We know that because it's a right triangle, it equals c squared, except it's the whole quant, we'll do c squared. Going to do a little FOIL action because it's fun, and the problem is requiring it. Mostly it's fun. All right, good news again, x squareds, when we subtract them from both sides, they're gone. So we get 49 here. And so we can subtract the 1 from 49 and get 48, right? So that'd be 49, subtract the 1, we get 2x, so x equals 24. Bam. All right, to find the missing side, tell if it's a triple. It can sort of be in the form of a triple, even if it's not sort of a triple. Like if I double these, right? This is going to be 5 if I double it. In other words, this is going to be, essentially 5 sort of divided by 2. And this is going to be 13 divided by 2. So 5, 12, 13 is 1. So this is going to be 12 divided by 2, aka 6. So this is a triple. Okay, this is 15, 20. This is 3 times 5. And this is 4 times 5, which means it's a 3, 4, 5 times 5, 25. That is also a triple. We're getting triples all up in this. This one's not going to be, there's no 2 something 7, so we're going to do a little 2 squared plus x squared equals 7 squared, so 49. And then we subtract 4, so we get 45. X squared equals 45. So 45 is what? 15 times 3, right? So 20, is that right? So yeah. Oh, 9 times, better, 9 times 5. Okay, so we can take out that, make it 3 radical 5. Okay. All right, so now we got sort of tell if they can be the side lengths of a triangle. If so, we'll classify it. So 10 plus 12 is bigger than 15. 8 plus 13 is 21, not bigger. So we can just go ahead and say not a triangle in this one. 9 plus 14, 23, is bigger than 17, triangle. Okay, now let's go back and classify the two that were remaining. So we know we have 15 squared, which is 225. We've got 100 plus 144, so 244. So which one is bigger? 225 is smaller. So C, I look at C, right? So we know this side C. So C is smaller, so it's acute. Okay, now a triangle. Let's look at this one. We get 9 squared is 81. 14 squared is 196. So notice by my inflection, I didn't really know. I went up like that. All right. So I also am going to check this one. So we'll do 14 squared and 17 squared just to make sure. 6, what was it? 17 times 17, 289. Okay, 289 and 81 is going to be 277. So, and 289. So we get c squared is bigger in this case. So because c squared is bigger, it's going to be obtuse. So just think about it in terms of c squared, and you should be good. All right. So here are some fun ones. Is this it? Yeah. All right. I'm just trying to find x. Okay, so this is 9, 15. This is actually going to be a 9, 12, 15. That is a 3, 4, 5. Again, you could do Pythagorean theorem if you want to. Okay, so if this is 12, then, and the whole thing is 25, that must make this side right here 13, because 13 plus 12 have to give me that 25. Now I can do Pythagorean theorem and say, you know what, I should have some sort of symbol for triple or something, I could just maybe say like 3, 4, 5 or something. I don't know. It's not really a good symbol. You need like a bad signal or something. Okay, so we get 81 plus 169 equals x squared. Then we get, let's see, 250 equals x squared. And so radical 250, we get x. I'm just going to move it over there. And so that's 25 times 10, so it's 5 radical 10. All right. All right, this one, let's see. We always want to see what we can do, right? So in this case, we have a right triangle here as well. Oh, so 6, 8, 10. Again, that's also a 3, 4, 5. It's just, 2 times that. So we can do that there. I'll just put a check, like if it's a triple. Bam. All right. So then if this part is 8, okay, that was an easy one. We still need to find this part, because then we can add them together to find x. So we're still going to have to say, all right, well, 6 squared plus this missing piece, which I'll call x squared, equals 7 squared, so 36, plus x squared equals, that's supposed to say 49, 40. I was going to write, oh no, I think I was going to write 7 squared, but just went straight to 49, but there we go. Now we got both. All right, and we got 13, so radical 13 is going to be x. Yep, and so this is radical 13. So together, x is just going to be 8 plus radical 13. Can't combine them, so I love that answer. Awesome. All right, so we got to start with the 7 and 2 business here, because then what we can do is we basically have to work our way backwards, right? We're thinking, well, what can we do? Well, we know 2 sides of this right triangle, so I can find this side here. So I'm going to do that first. So we can say, 2 squared plus this missing side. Let's call it x, because that's what we like to do. 2 squared plus x squared equals 7 squared. So that's going to be 45. Then I think I did one like this already, actually. So this we already said was going to be, 9 times 5. So 3 radical 5 is this one. Okay. You know what? We could leave it as radical 45 as well if you want to, because we're just about to square it, right? So I could say, radical 45. I mean, yeah, 3 radical 5 if this was your final answer, but this isn't my final answer. I want to find this. And so now we have 2 sides of this right triangle. So we're thinking, okay, let's do this. We can do 5 squared plus x squared equals c squared, which I just found was radical 45. And see how I left it here, because I have to square it anyway. And so it just goes away, right? It just becomes 45 anyway. And so we get 25 plus x squared. So 20 equals x. So it looks like 2 radical 5, because that was 4 times 5, is going to be x in this case. All right. Find the perimeter and the area of each figure. Okay, so we got to go perimeter and area. So let's find the missing side. This is actually an 8, 15, 17, so we're good actually there. Okay, so to find the perimeter, we just have to add all the sides, right? So 15 and 17 is 32, plus 8 is 40. So again, add all the sides to find the perimeter. Area, we know in a triangle is 1/2 base times height. But our bases are going to be the legs, so that's 8 and 15. So we'll do half of 8, which is 4. 4 times 15 is 60. So don't have any units, so area is 16. So perimeter and area. So find the side that you know first, and then go from there. Okay, so we don't really have enough to find. We have 2 8s, but we need to find the bottom one. So we can just say, all right, well, 6 squared plus a missing value, x squared equals 8 squared, 36. 64, x squared plus equals. So x squared equals 28, which is 2 radical 7, right? Because that's 4 times 7. So 2 radical 7. So this is 2 radical 7. This is 2 radical 7. So our sides are 8 and 8, which is 16. So this is our perimeter. And then our bottom side is 2 radical 7 and 2 radical 7, aka 4 radical 7. So that's our perimeter. Love it. Great answer. Our area is still 1/2 base, which our base, we already said, was 4 radical 7. Our height they gave me was 6. So we can just say 2 times 6, 12 radical 7 is going to be our area. All right. Cool, cool, cool. All right, and then this one we actually had the perimeter already, because we have 24, we have 32, right? Is our perimeter. They already give us all the sides, which is very kind of them. But we need to actually think, well, if this is 12 and this is 12, this cuts it in half, so this is going to be 4 and this is going to be 4. So we are going to need to find this height to find, because basically we get to this point where like, oh, 1/2 the base is 8 and the height is, oops, missing it, don't know it. So I got to do Pythagorean theorem in this case to find it. So we're going to say 4 squared, because I'm just trying to do this right triangle in here. 4 squared plus this h squared equals 12 squared. So 16, 144, so 128. H squared equals 128. That's 64 times 2, so that's going to be 8 radical 2 is our height. So 8 radical 2 in here is the height. Okay, oops, a little further. There we go. And so we could just say, 4, so 4 times 8, 32 radical 2. We just stick that on like a variable at the end. All right, nailed it. Pure perfection. Did most of these in class, but we'll run through them anyway. All right, so get what we can here. Basically, I'm thinking to find x, we need this side. Well, I can find this side by doing Pythagorean theorem. So we can do 3 squared plus, I'll call that h just because x is already there. And then it's going to be equals radical 34. That's just 34. Don't judge me. Squared. So we get 9 plus h squared equals just 34, right? Yeah, 25. H squared equals 25. H is 5. So this is 5. Okay. And so now we can do Pythagorean theorem to find x. We can basically say 5 squared plus x squared equals 11 squared. 121 minus 25, right, is 96. Okay, I'm doing these in my head. I think they're good. Yeah. And so x is going to be, let's see. Let's see, 9 and 6 is, let's go with, I don't know, let's try dividing it by 4. Yeah, okay, you know what, 96, I bet is divisible by 36. Oh, made that up, 96. Yeah, 16 times 6, there we go. All right, so it's going to be 16 times 6, which is just going to be 4 radical 6. Bam. See, a lot of these are just two-step problems. All right. All right, so in this case, we know that because these are the same, this is going to be 5 as well. So this is actually a 5, 12, 13. And now we're looking at sort of this triangle here as another right triangle. So now we have two sides of it. Actually, this is actually another triple. So this is going to be 12, which means, and this side, again, that 12 is another 3, 4, 5 situation, right? So we can sort of say that's a triple. And that would be, again, 3 times 4, 4 times 4. So this whole thing is going to be 16, and then 5 times 4. So then if this is the whole thing is 16, and that's 5, then we know that the x has to be 11. So that was sort of, again, see how you can make your life easy with triples. If you didn't know the triples, you'd end up having to do 2 things there, 2 Pythagorean theorems. Okay, which you can do if you have the can-do attitude. Okay, so in this case, we have this here, where that is horrible. Whatever, I'm going to pretend that that is straight. Okay, so basically we have, and we can do that because once I find this side, I can divide it in half and then deal with it over here. Okay, so basically what it comes down to is if you can find a right triangle, they know 2 sides, so find the 3rd side. It's not a bad option. Let's see, 9 and 15. Okay, so this is also a triple if I'm not mistaken. So I can put a check there because that is going to be 3 times 6, and this is going to be, so it's 3. Sorry, it's a 3, 4, 5 because it's times 6, because that's 5 times 6. So this is going to be 4 times 6, 24. And so that means this has to be 12, this has to be 12, and this has to be 12. We still have to do Pythagorean theorem to find this one because we have this side and this side to find x. So it's going to be 18 squared plus 12 squared equals x squared. And we can do that. Might as well, right? 18 times 18 plus 144 is 468. And then radical 468 is not anything cool. So let's see, we get x equals radical 468. Let's start dividing that thing maybe by, let's see, 468 divided by 16. Nope. 468 divided by 36. Nailed it. All right, so it's going to be 36 times 13. And so that's going to be 6 radical 13. Once you get to a prime, you know you can't go anymore, so you're good. So you are good. I said that kind of whatever. All right, we're done. 5.7. Nailed it.